can simplify. So I can simplify a factor from the top and the factor from the bottom. So then the function is now this function. Perfect. So now we can start our table. Yes, Danielle, any questions? Go ahead. Oh, okay. Just my dream. Okay, so let's start with the domain. What is the domain of this function? And remember, we're not graphing this. It turns out that it's simplified. Now, we're not graphing this, we're graphing this. So please tell me what is the domain of this function. But we already have two restrictions. How can it be? This is not a polynomial function. This is a function with problems, asymptotes, all sorts. So what is the domain? -1, 0, infinity. This function is clearly undefined at -1 and -2 as we established from the beginning, correct? Is that clear? Okay, perfect. So now, which factor went away completely and did not stay in the final simplified form? Right, which is this? This will not be a vertical asymptote, but a hole in the graph. Which factor stayed forever in the simplified form? There is no around it. No way around it. X equals -2 is a vertical asymptote. So this was the exception. Remember I said every time a rational function is undefined at a point, it has a vertical asymptote. And I said with one exception. What is the exception? Is when the factor goes away. X plus 1 went away. That's why this is a hole. It's not in the final form. The one that I can never get rid of is a vertical asymptote. It doesn't mean that the function is defined here. It still means it's not defined, but it's not going to have a vertical asymptote at that point. So left and right will not be infinities. Here for the vertical asymptote, left and right will be infinities. So I'm going to put them in and determine with -2.1 and with -1.9. The sign, just the sign. So let's plug in -2.1 here. Just give me the sign. Negative. The top is positive because it's 1 over negative. What is the sign? Perfect. So please plug in, replace x by -1.9 and just give me the sign of the expression. Just the sign, positive. And now we know that these will not be infinities. Let's plug in -1 here and tell me what you get. Exactly. And that's it on both sides. So the hole in the graph will be -1, 1. Since it's type 2, what would be the end behavior for all type 2? For all type 2 is 0. Always. So y equals 0 is a horizontal asymptote. One more step and we're done. Just please, for me, because this will never be 0, please plug in 0 and tell me what to write here under for the y-intercept. We agree with 1/2? Is it good? That's all we need. Once you, yes?
So you plug like
-1?
I'm trying to figure out how to do the difference between vertical asymptote and horizontal asymptote.
Ah, the horizontal asymptote is the end behavior.
Okay.
The vertical asymptote is where the function is undefined and the factor doesn't go away, where the sides go to infinity or -infinity.
Okay. So would that be that's a y then? The horizontal.
The horizontal asymptote is y. It's a horizontal line. The vertical line is x equals. Yes. Any questions here? Let's try to make sense of this. Yes.
How do you get the positive, negative, infinity, whatever? How do you do that again?
Okay. So I know now that x equals -2 is a vertical asymptote because the factor doesn't go away. So I will plug in a number as close as I can from the left of -2, which is -2.1, and one from the right of -2, which would be -1.9. When I plug this in here, I get a negative number. Positive of a negative would be negative.
So, well, 2.1 goes to the left and then 1.9 goes to the right. Is that what you're saying? Yes, it would.
Yeah, because
Okay.
-2.1 is smaller than -2.
I made it more difficult.
That's okay.
Yeah.
So then when I plug in -1.9, I get a positive number, so that's how I get the positive. Better?
Thank you.
Good. So now let's make sense of this. Yes, please, Eric.
How do you get 0 as the MPH again?
Here, by definition, this happens. I can show you the theory behind it if you want, but I'll explain. I will say this: that for all type 2, the end behavior is 0, and the horizontal asymptote is 0. I can show you why. So let me show you why. So as x approaches infinity or negative infinity, how much is infinity plus 2? Still huge. And if I want to divide 1 by 1,000,000, what will I get? Close to 0. Like my silly example with the cake. Right? So I divide 1 cake by 1,000,000 people. No one will get anything. So that's why it's 0. Okay, so now let's make sense of this information. Okay, we have a vertical asymptote at -2. It's coming from 0, going to negative infinity. That's done. On the other side, from positive infinity, it's going through a point -1, 0. It's crossing the y-axis at 0, 1/2, going to 0. That's it. One more time. So from 0 to negative infinity. This is a vertical asymptote. From positive infinity, going through this point -1, 0, crossing the x-axis at 0, 1/2, going to 0. Yes, please.
Would it be -1, 0 or -1, 1?
-1, 1. Okay. Did I say -1, 0? Sorry. I meant -1, 1. Sorry. So let's put the points first, or the asymptotes first, but they have to be the preliminary. So this is an overkill. There is no need to do this unless you want to. I always do, but there is no need because the y equals 0 is the x-axis, the x-axis. So -2 -1, 1 and 0, 1/2. Okay, one more time. I have the vertical asymptote, which is x equals -1. I have the hold it, which is -1, -1, 1. I have 0, 1/2. And now from 0, it goes to negative infinity. On the other side, from positive infinity, going through this point, crossing the y-axis at 0, 1/2, and approaching 0. That's the whole thing. From 0 approaching negative infinity, from positive infinity crossing, going to infinity. When x approaches infinity, y approaches 0. So this is our function f of x plus 1 over x squared plus 3x plus 2.
I know this was a few steps ago, but just for my notes.
Yes.
How did you get the 1 on either side of -1?
Perfect. In the simplified form, not in the original one, because in the original one I would get 0 over 0.
Yeah.
But in the simplified form, I plug in -1.
And so-
-1 plus 2, I get 1. 1 over 1 is 1.
Okay.
Once I know the whole here, I cannot have infinities left and right, because this is not a vertical asymptote. So with the graphing calculator, make sure that in y equals, you clear everything. There is no need to put y equals 0 because the graphing calculator will graph the x-axis. So parentheses, x plus 1 divided by parentheses, x squared plus 3x. Oops, I didn't mean that. X squared. I didn't mean that either. What is this? What is this? Never mind.
Yeah.
Okay, x plus 1 divided by parentheses x squared, and I want plus 3x and plus 2. And let's use the standard viewing window for now.
Do you have to put anything more?
No, because it's the x-axis.
So
For
it's
type 2, yeah, it will graph. You can if you want to see it, we can put 0. That's fine. And let's use them 6 again. See what happens. Here it is. And the horizontal asymptote, which is the x-axis. Now, that's not clear. You didn't talk right now, right? No, Danielle, you didn't. Okay, I need a hearing aid. So I'm looking at this point. So let's take a look.
I'm sorry, I'm so excited.
Yes, go ahead.
First time I've ever done it.
Sorry. Good. Are you happy
Yeah,
about
you're
it?
not
Good. So let's take a look at this. So I'm going to zoom in. So I only care about a -3 to 1 for x.
Wait, what are we going to find right now?
I want to show something. -3 to 1. In a second, I'll come back. And let's say -2 to 2. Here it is. It better be there. Ah. It's clear that it's not a vertical asymptote, correct? It's a hole in the graph. Because if it were a vertical asymptote, the function would have done this.
I have it on top.
Say it again.
I have a vertical asymptote on mine.
Oh, you do, but not for that point. You have it for not for this point. But you have it. We all have it. It's just in the software for some reason I can't. But not at -1. At -1 you have a hole. At -2, yes, you have a vertical asymptote right here at -2, but not at -1. Is that okay? Perfect. So basically this is it about rational functions.
So the only difference between type 1 and type 2 is type 2 has a hole in it?
No, it just happened that I showed an example with a hole in it.
Okay.
The only difference between type 1 and type 2 is the horizontal asymptote.
So any of them can have a hole?
Yes.
Okay.
And
very
how do
good.
you know if it's a hole?
If you cannot simplify, if you simplify a factor, if one factor goes away when the function is undefined. Yes. When the function is undefined, then one factor goes away. So if the factor goes away, it's a hole in the graph. If the factor doesn't go away, it must be a vertical asymptote. Very good questions. Thank you. Anything else you would like to go back here? Anything else? Anything else? Okay, let's look at type 3.
Is this 3.3?
This is 3.5.
Okay.
And we have one more section.
Okay. So the test will be next week.
Yes. So test 2, we hope to have it next week, and that's why I gave you today a little packet. So I will, hopefully, this is what we are going to do on Thursday, a review.
Oh, so the test will be on Tuesday?
Tuesday or Thursday, it doesn't matter. I just wanted to let you know that I have a review with my, so Math 137 review this Saturday. I have no idea what day it is. What day is Saturday? If today is the 23rd, 27th? Thank you very much. Okay. I will be at Arundel Mills in room 401 from 7 a.m. to 8:30 a.m.
If you're coming, bring your jackets. It's cold in that room.
So please do come if you can. Okay, there is no traffic at that time. It's quiet in the building. It's going to be very good, and we're going to review whatever you need for an hour and a half. I have to leave at 8:30 because I have a workshop to go to. So otherwise I will stay longer and I will move it a little bit later, but I can't, and I'm hoping that you can make it. So test 2 will have 2.5 through 2.8 and chapter 3, only what we covered, of course, nothing else. And it will be next week, either Tuesday or Thursday. Hopefully, I would recommend Thursday. So we'll see. Okay? So please do as much as you can between now and next. Danielle,
I was
please.
talking about what we recommend.
Please. Okay, thank you. So till next Sunday, as much as you can, and I will allow you to continue afterwards, but I like us to have a good basis for the test. And we will review. Okay, type 3. So here it is. F of x equals x squared plus 3x plus 2 divided by x minus 4. I would like you to pay attention to this. It's not going to be difficult. It just involves something we just did from the previous section. It's not going to be difficult. I promise you it's going to be one of the extra credit to choose from because it's a little bit longer and I don't want you to spend 15 minutes on it. Okay. What type is it? It's a rational function, but what type is it? Degree 2 at the top and degree 1 at the bottom. So it cannot be type 1 because that requires both degrees to be the same. It's not type 1. Is it type 2 with higher degree in the denominator? No. So it's not type 2. So it is type 3. Type 3 meaning, one more time, the degree of the top is higher than the degree of the bottom, but exactly by 1 unit. If it's by 2 units, it's none of the above. And we cannot graph them in this class. Okay? So it must be 1 degree higher than the bottom. And it is. It is type 3. Good. What do I have to do immediately? Yes. So I'm using the same top as we did before. So x plus 1, x plus 2 divided by x minus 4. Very good. So f of x. So there is only one minor difference. Just one difference between type 3 and the rest, type 1 and type 2. What is it? It's not going to have a horizontal asymptote. The quotient of this division will be a slant asymptote. That's the only difference. Okay? Good. So forget about that for a moment. Let's do what we already know how to do here. The domain, please. Awesome. So 0 has to be in the table, 4 has to be in the table, and it cannot equal 4. Will x minus 4 go away with a factor of x minus 4 from the top? No. So then what is x equals 4 for sure? Awesome. Once we said vertical asymptote, I put immediately the infinities left and right. But there is one thing I don't know. What I don't know is signs. What will I use to plug in?
3.5.
Yes. The problem is that if I put 4 in here, I will get a non-defined situation. I will not be able to determine the sign. So I will have to use 3.9, something close, and 4.1. Notice that I do not put them in the table. I'm not going to plot these. They will only help me find the sign of these infinities. With 3.9, the top is all positive. What about the denominator? Negative. So positive over negative will be good. With 4.1, everything is positive at the top. What about the bottom? So what will be the sign? That's all I care about. Once I establish that x equals 4 is a vertical asymptote, I know that these must be infinities, and the signs will be determined by numbers because I cannot plug in 4. I wish I could, but I can't. When I plug in 4, I get nothing. Good. So now I want the x-intercepts and the y-intercept. So 0, 0, 0. When I plug in 0, I get 2 over negative 4. What is that? Perfect. I want the x-intercepts. When is a fraction 0? A fraction is 0 when is 0. When is the numerator 0? X is negative 1 or x equals? That's it. So negative 2, 0, negative 1, 0. That's it. Final step, I need to divide these two to find the quotient.
You have to divide it.
Yes, to find the quotient, which will be the line. Can I use synthetic division on this? Not on this. This was factored for other things. It was factored for the x and y intercepts, and for domain and so on and so forth. I need to divide those. You want to use synthetic division or long division? Perfect. What goes in the box? What goes in the box? 4. And the coefficients will be 1, 3, 2. We copy the first coefficient. 4 times 1. 3 plus 4. 4 times 7. In the box. So then, this function can be rewritten how? Awesome. Awesome.
And then it would be whatever.
But I need the sign. 30 over x minus 4. This is the slant asymptote. Y equals x plus 7 is the slant asymptote. Here's why. For the same reason you asked this wonderful question before, remember? At x, when x approaches infinity, this will approach infinity. What will this approach? 30Ks for 1 million people. What will this, where will this go? That's why it's disregarded. So I will go back here and I will write y equals x plus 7 is a slant asymptote. And now the end behavior, the function must follow the asymptote. So since the leading coefficient is positive, will this function look like this? Or it will look like this? So that's the end behavior of the function itself as well. It has to follow the asymptote. So then I have a negative infinity to infinity. Okay, so we finished this one up. So here's what we see. When we graph a function with asymptotes, we have to graph the asymptotes first. So the first one is the vertical asymptote x equals 4. The other one is the slant asymptote x plus 7, y equals x plus 7. When x is 0, y is 7. 1, 2, 3, 4, 5, 6, 7. When y is 0, x is negative 7. Here it is. So this is y equals x plus 7. So now to make sense of the information we have, I graph the asymptotes. I can graph plot negative 2, 0. I can plot negative 1, 0. I can plot 0, negative 1 half. And that's all I have. So the function is coming from negative infinity, approaching the asymptote, and goes up, crossing, and going to negative infinity. From negative infinity, crossing, negative infinity. On the other side, how is that possible? There is no function that does that. There is this function that does that. There's no function that connects straightforward, infinity to infinity, so it has to come to a minimum. So that's what's going to happen here. You're not surprised that I ran out of room, right? Good. Neither am I. So the graph should look like this. And a maximum here. It's a little bit stretched at negative 2 and negative 1. So when we put it in the graphing calculator, we do have to put two functions in there, of course. So in y equals clear, the second one must be x plus 7. And then the first one is in parentheses for the top. Please be very careful. X squared plus 3x and plus 2. And we divide by x minus 4. I don't know anything about the viewing window. It's really difficult for this one. So I'm going to change it to, I don't really want a lot of x, but I need probably a lot of y in the positive. So I'm going to put -10 to +10. I don't need that +10, +5, it's good enough. With a scale of 1. Y minimum, I don't care for a lot of minimum, -2. But the maximum, I don't know, it could be even 50. I don't know how high that is with a scale of 10. So let's try -10, 5, 1, and -2, 50, 10. I'm not sure. We may have to come back and adjust. And from my little cheat sheet over there, obviously it's not the best option. We know that this cannot happen. The function cannot go on the x-axis like that. Okay, so it's not good enough. I have to show a lot more on this side. So, okay, I'm going to say 20 here with a scale of 5. And let's see if that's better. Yeah, that is better. So it's coming from -infinity, crossing at -1 and -2 and -1. And then it's coming from +infinity and approaching the asymptote, and there is a minimum here. Now you understand that this is a more sophisticated type of problem, and that's why I don't think we are going to see this again. There are more important applications in chapter 4. And I can't really give you an application of this. I can give you applications, plenty of applications of type 1 and type 2. I cannot really give you an application of type 3. Yes, we can determine this minimum, and we can determine this maximum between -2 and 1. We know that this is not true, correct? Okay. Very good. So my plan for Thursday